Anatomy of a processor in Apache NiFi. Here you can see anatomy of a processor. NiFi provides a significant amount of information about each processor on the canvas. This diagram shows the anatomy of a processor. This has the number of elements. Processor type. NiFi provides several different types of processors in order to allow for a wide range of tasks to be performed. Each type of processor is designed to perform one specific task. The processor type put file in this example describes the task that this processor performs. In this case, the processor writes a flow file to the disk or puts a flow file to a file. Bulleting indicator. When a processor logs that some event has occurred, it generates a bulletin to notify those who are monitoring NiFi via the user interface. The DFM is able to configure which bulletins should be displayed in the user interface by updating the bulletin level field in the settings tab of the processor configuration dialog. The default value is warn, which means that only warnings and errors will be displayed in the UI. This icon is not present unless a bulletin exists for this processor. When it is present, hovering over the icon with the mouse will provide a tooltip explaining the message provided by the processor as well as the bulletin level. If the instance of NiFi is clustered, it will also show the node that emitted the bulletin. Bulletins automatically expire after 5 minutes. Status indicator. This shows the current status of the processor. The indicators, the possible indicators are running. The processor is currently running and stopped. The process is valid and enabled but is not running. Invalid, the processor is enabled but is not currently valid and cannot be started. Hovering over this icon will provide the tooltip indicating why the process is not valid. And disabled, the process is not running and cannot be started until it has been enabled. This status does not indicate whether or not the process is valid. Here you can see running state, running status indicator here. Processor name. This is the user defined name of the processor. By default, the name of the processor is the same as the processor type. In this example, the value is copy to /review. Active tasks. The number of tasks that this processor is currently executing. This number is constrained by the concurrent task settings in the scheduling tab of the processor configuration dialog. Here we can see that the processor is currently performing one task. If the NiFi instance is clustered, this value represents the number of tasks that are currently executing across all the nodes in the cluster. 5-minute statistics. The processor shows several different statistics in a tabular form. Each of these statistics represent the amount of work that has been performed in the past 5 minutes. If NiFi instance is clustered, these values indicate how much work has been done by all the nodes combined in the past 5 minutes. These metrics are in the amount of data that the processor has pulled from the queue of its incoming connections. This value is represented as count and size, where count is the number of flow files that have been pulled from the queue, and size is the total size of those flow files content. In this example, the processor is just pulled 29 flow files from the input queues for total of 14.16 megabytes. Read write. The total of the flow file content that the processor has read from the disk and written to disk. This provides valuable information about the I/O performance that this processor requires. Some processors may only read the data without writing anything, while some will not read the data but will only write data. Others will never read nor write data, and some processors will both read and write data. In this example, we see that in the past 5 minutes, the processor has read 4.88 MB of the flow file content and has written 4.88 MB as well. This is what we would expect, since this processor simply copies the content of the flow file to the disk. Note, however, this is not the same as the amount of data that pulled from the input queues. This is because some of the files that it pulls from the input queues already exist in the output directory, and the processor is configured to route flow files to failure when it occurs. Therefore, for those files which already existed in the output directory, data was neither read nor written to disks. Out. The amount of data that processor has transformed to its outbound connections. This does not include flow files that the processor removed itself, or flow files that are routed to connections that are auto-terminated. Like in metric above, this value is represented as count, where count is the number of flow files that have been transferred to outbound connections, and size is the total size of those flow files content. In this example, all of the relationships are configured to be auto terminated, so no flow files are reported as having been transferred out. Tasks time. The number of times that this processor has been triggered to run in the past 5 minutes, and the amount of time taken to perform these tasks. The format of the time is hour, minutes, and seconds. Note that the amount of time taken can exceeded 5 minutes, because many tasks can be executed in parallel. For instance, if a processor is scheduled to run with 60 concurrent tasks, and each of these tasks takes 1 second to complete, it is possible that 60 tasks will be completed in a single second. However, in this case, we will see the time metric showing that it took 60 seconds instead of 1 second. This time can be thought of as system time, or said another way, this value is 60 seconds because that's the amount of time that would have taken to perform action if only a single concurrent task were used. And here you can see a processor. Here you can see a status symbol, processor name, processor type, 5 minute statistics, bulletin indicator, and active tasks. Now this is the end of my presentation. Thank you very much for watching it.